we are really thankful for having the opportunity to present you our research project in which we, together with our Professor Niels Bartels, analyze the environmental sustainability of smart buildings. At first, I want to present you our methodology of our research project as well as for this presentation. We started with literature research on the key terms smart building and environmental sustainability. Based on this, in our first step, we analyzed 15 smart offices in Germany and Central Europe to evaluate the link between smart offices and sustainability. Therefore, we asked about the implemented use cases, their pertinence and their frequency of use. Later in expert workshops, we structured them with according to the potential on the 3 pillars of sustainability. In the second step, through expert interviews, we worked out limitations in the sustainability analysis of smart buildings due to incomplete data availability. Finally, in the last step, we determined the necessary data of smart offices to analyze its environmental sustainability. During our literature review, we noted that there is no uniform definition of smart buildings, which is indispensable to compare smart buildings with each other. Due to this, we create a standardized definition, which is shown in this figure and you can find in detail in our paper. In order to measure the smartness of a building, the European Union defines a smart readiness indicator. This indicator can be used to assess the readiness of a building for the implementation of smart components. However, it does not provide a basis of assessing the sustainability of smart buildings. However, research revealed energy savings in smart buildings of 10 to 25%, but further analysis of more than 20 companies in the smart building sector, there is no substantiated statement on possible savings through the intelligent applications in buildings. The evaluation revealed some difficulties in assessing the actual savings and optimization potential in standard buildings compared to smart buildings. To find a solution for this problem, we started with the analysis of the sustainability of smart offices. As explained above, in step 1, we can identify 64 use cases in 7 main categories, such as infrastructure management and building security, through the analysis of 15 smart offices, which are illustrated in this figure. The further out the use cases are placed, the more frequently they are implemented. The use cases with an impact on the environmental sustainability are presented in bright green, for example, room booking or daylight-depending lighting. 72% of the use cases affecting the environmental sustainability were implemented in less than 33% of the analyzed smart offices. This fact challenges the notion that the smart systems are primarily implemented for environmental reasons. On the other hand, more than the half of the other use cases were implemented in more than 33% of the smart offices. This figure reinforces the results shown above. Only 6% of the use cases exclusively impact the environmental sustainability, while 61% influence the environmental and economic, and 33% influence the environmental and social sustainability. These results show a predominant focus on the user satisfaction and experience, as well as a cost-effective building operation, and demonstrates that the environmental sustainability emerges as a byproduct of the implementation of smart buildings. To summarize the results of the building analysis regarding the implementation of use cases, various trends for optimizing the environmental sustainability of smart buildings are recognizable. For example, use cases like workplace booking and different space management use cases can reduce the gray energy and by reducing the required area. Use cases for optimized energy use, such as smart ventilation or heating and individual comfort settings, are gaining relevance. At least some experts note that the environmental sustainability of a building can be improved by optimizing and expanding the relevant use cases, as you can see here for smart metering. However, in order to achieve this, data availability in smart buildings is curricular, and which we evaluate in the next step, and Sara will now present to you.
Thank you. A smart building requires the effective use of data. It is necessary to capture the data from the building management system, integrated use case, and so on. All data must be available over the entire life cycle in order to be able to derive optimization potential from the data. We requested experts for an interview from 67 companies, for example, like asset managers and facility managers, general constructors, hard and software manufacturers in smart building sector, and project developers about their use of the collected data in smart buildings to identify the data flow and losses. The figure on the left shows that the initial situation regarding the data availability in the real estate sector. You can see that 60% of the questioned company, it's marked in orange, collect building operation data, either directly by owners, FM, or third-party providers. 28% plan to collect data, while 12% have no plans to do so. Among the companies that collect data, 20% do not use the data any further, and storage locations are often unclear. The remaining 80% of the data for facility management, support system optimization, or sustainable operational control. The remaining 80% use the data for FM support system optimization or sustainable operational control. This represents 48% of all interviewed companies. Almost 70% of all interviewed experts do not store the data centrally in the cloud. Those who store the data are manufacturers who offer cloud storage as a service. Hard and software manufacturers also account for 75% of those who collect data from a building. This involves customer data. Therefore, manufacturers are not able to control or to guarantee that the collected and stored data will be used to promote sustainability. In total, over 50% of the interviewed companies do not use building technology or energy-related data for optimization in their buildings. Only 4 interviewed experts were able to provide data from their smart buildings so that we could analyze the operation. For various reasons, the others could not share the data. The received data was partly implausible and incomplete. Due to the lack of data quality, no conclusion could be drawn about the operational sustainability of the analyzed smart buildings. But we were able to define relevant data which need to be collected to evaluate and also improve the sustainability of office buildings. Here you can see the data table in a very simplified form. It is necessary to record the energy consumption data like technical current or heating and cooling consumption. The technical current, for example, needs to be recorded separately for systems like elevator, ventilation system, or heating generation system in 50-minute intervals. You also need to provide the planning documentation for building service engineering. It's important to know the building automation and the building operation to evaluate the data. If you're interested in more details, you can find them in our paper, including an explanation why the corresponding data is so important. And at least conclusion, limitations, and forecast. One of the main conclusions of our paper is that there's a huge potential for using data to optimize buildings, but we need to have a Europe-wide, at least German-wide standard standard for the data storage and processing. Our paper is limited by the locations of the investigated smart buildings. In addition, the sustainability of smart buildings could not adequately be confirmed due to the lack of data. In the future, a comparison of high-tech and low-tech buildings is required with regard to the sustainability of building operation. Therefore, it is necessary to analyze the impact of the embodied carbon of the implemented hardware and emissions of the cloud storage. Only then a final assessment can be made whether smart buildings are the solution for the sustainable building operation. Thank you for your attention.